Central limit theorem, or in short we write it as CLT. So this is, by the way, the most important theorem in mathematical statistics, right? Without this theorem, there are so many concepts which can't be explained. But so this is a very important and central theorem, and that's why it's called a central limit theorem. And what's the statement? Let a variable x has a distribution, and that distribution may or may not be normal, may be normal or may not be normal, and that has a mean of a mu and a standard deviation of sigma. Let all simple random samples of size n are selected from the population. Now we have three scenarios or three cases. The first one, if n is greater than or equal to 30, n stands for the sample size. If the sample size is greater than 30, then the sampling distribution, what I mean by the sampling distribution, I mean that this distribution, the distribution of variable x bar of sample mean is normal irrespective of the parent distribution, where the mean of the sample mean is equal to a population mean and the standard deviation of the sample mean is equal to standard deviation of the population divided by the square root of the sample size. It means if this happens, then these two conditions also, these two formulas also hold. Main formulas for a central limit theorem. So once again, if the sample size is greater than or equal to 30, now the question that comes to the mind, what is this 30 is about? Why not 29? Why not something else? Why 30? So remember, this 30 is a kind of a magic number, right? Actually, the statement is, the actual statement is that if the sample size is sufficiently large, and the statisticians agree that when the sample is 30 or more, we will regard it as a sufficiently large for most practical application. I repeat this once again, this 30 is a magic number, and this 30 comes from the fact that our sample size has to be sufficiently large, and the statisticians agree for the most practical application, the 30 or more is regarded as sufficiently large sample size. So if the sample size is sufficiently large, then the sampling distribution, which is the distribution of x bar, is always normal irrespective of the parent distribution. I don't care what is the parent distribution is, what the distribution is coming from, and with the sample mean of the sample mean is equal to population mean, and the standard deviation of the sample mean is equal to standard deviation of the population divided by square root of n. Let's go to the second case. If n is less than 30, which means if what happens when the sample is not sufficiently large, n is less than 30, and the population is normally distributed. Look at this, there is an additional condition on that, and that's the condition. And the population is normally distributed, then the sampling distribution of a sample mean is approximately normal, with the mean of the sample mean is equal to population mean, and the standard deviation sample mean is equal to standard deviation of the population divided by the square root of the sample size. Look at the third condition, third scenario. If sample size is less than 30 and we have no information about the population, about the parent distribution, then what happened? This central limit theorem, we are unable to draw any conclusion from the central limit theorem. So it's very important that you understand all these three scenarios and how they are applicable. You will understand more about all these three cases when I take a practical example, and in this case you will be able to better understand what this central limit theorem is saying. So let's see few examples. Now let's see one of the example for the central limit theorem. The weight of a population, the weight of a people, in a certain population are normally distributed with a mean of a 157 pound and a standard deviation of 23 pound. Find the mean and the standard error. Standard error. So you might be wondering what the standard error is. I will explain this. What is the standard error? It is the standard deviation of the sampling distribution of the mean for this sampling distribution when using a random simple random sample of size 8. Okay. So I have on this right side I have written the central limit theorem. It's very important when you are solving the problem for the central limit theorem, this central limit theorem must be in front of you. You should have a clear idea what we are talking about, and you should keep this in front of you. And for your convenience, I have written the main idea in the central limit theorem. Let's start with the first one. Look at the sample size. The sample size, this is n. So our n is equal to 8, and that is definitely less than 30. Okay, so look at which case will be applicable. N is not greater than 30 and n is less than 30. Okay, and x is normal. Let's look at whether our population is normal, and look at that. The weight of the people in a certain population are normally distributed. Look at that, normally distributed. It means our parent distribution, the distribution from where we are getting the sample, is called the parent distribution. I'm using this word in a loose sense. There is actually no parent and a child distribution, honestly, but just to make the concept more clear and more understandable, I sometimes use the parent distribution and a child distribution in a loose sense, but it's not a technical term. So the parent distribution happens to be normal. It means the sampling distribution, look at that, x bar is normal or approximately normal, right? So we were going to say as n is equal to 8, which is less than 30, and x is normal. It implies that the sampling distribution is also, I'll say, approximately normal. Let's write approximately normal. Right? This is what the central limit theorem says. And what is the mean? The mean is the mean of the sample mean will be equal to the population mean, and the standard deviation of the sample mean, which is equal to standard deviation of the population divided by the square root of the sample size. This is also called the standard error. This is also called the standard error of the mean. Let me write here, standard error of the mean. This standard deviation, I also mentioned here, standard deviation of the sampling distribution. This is also called the standard error of the mean. So now we have the two formulas. We have the formula for the mean, and we have the formula for the standard error or the standard deviation of the sampling distribution. Now we can compute. Look at that. Mean of the sample mean will be equal to the population mean, and that mean is 157. So we are done with that. So we're able to find that. Now let's move to the standard deviation. The standard deviation of the sampling distribution is the standard deviation of population divided by the square root of the sample size. So let's write that. So the standard error of the mean is equal to standard deviation, which was 23 divided by the square root of 8, and that comes out to be 8.13. So we are able to find the mean, and we are able to find the standard deviation of the sampling distribution. I hope you are able to understand this example. Next, we're going to see another example. Let's see another example. So let's see another example. A variable of a population has a mean of 35. The mu is 35, and the standard deviation sigma equals to 42. Part A. If the variable is normally distributed, describe the sampling distribution of the sample mean for a sample of size 9. Part B. Can you answer the part A if the distribution of the variable under consideration is unknown? Part C. Can you answer the part A if the distribution of the variable under consideration is unknown but the sample size is 36 instead of a 9? Why or why not? We will see these parts one by one. First of all, you need to understand what is the meaning of this word describe. So first, remember, whenever you see a word describe the sampling distribution. What do you mean by the describe the sampling distribution? It means give me three things. Number one, give me the shape, give me the mean of the sampling distribution, give me the mean of the sampling distribution, And number 3, give me the standard deviation of the sampling distribution, which is also called the standard error. So I repeat once again, whenever you are asked to describe the sampling distribution, what does it mean? It means give me these 3 things about the sampling distribution. What is the shape of the sampling distribution? What is the mean of the sampling distribution? And what is the standard deviation? So let's see how we do that. Okay, look at the first part. We have a sample in the part A. We have sample size n is equal to 9. But what happens? The sample and the n is less than 30. But note that the population, he's asking if the variable is normally distributed. Look at that. So we already know the underlying population is normally distributed, and we know that if the underlying population is normally distributed, the sampling distribution of the sample mean is always normal irrespective of the sample size. So we are using the central limit theorem, the first one. So you will say as n is equal to 9, which is less than 30, but x is normal, the parent distribution is normal, it implies that the sampling distribution is always normal. Always normal. I don't care what is the sample size. If the parent distribution is normal, the sampling distribution of sample mean is always normal irrespective of the sample size. Right? This is from the central limit theorem. And now what is the mean? The mean of the sample mean is equal to population mean. And note the population mean is 35. So write a 35 here. Now what is the standard deviation? The standard deviation of the sample mean is always equal to standard deviation of the population divided by the square root of the sample size. This is the standard deviation of the population is 42. This is 42 divided by the square root of 9, and this turns out to be 42 divided by 3 is 14. So this is the standard deviation of the sampling distribution, and this is also called the standard error of the mean. Please, you remember this. You may be asked to compute the standard error, and you will then be surprised. What is the standard error? Okay. Now let's go to the second part, part B. What part B says, can you answer the part A if the distribution of the variable under consideration is unknown? Look at that. As the n is equal to 9, which is less than 30, and we have no information about x, the parent distribution, it implies no conclusion can be drawn. No conclusion can be drawn. Now look at the part C. He's asking, can you answer the part A if the distribution of the variable under consideration is still unknown, but the sample size is 36 instead of a 9, why or why not? So now note that n is here 36, which is greater than 30. Now use your knowledge of the central limit theorem. We know that if the sample size is greater than 30, then the sampling distribution of sample mean is always normal. It means I don't care what the sample size, I don't care what is the underlying distribution, as the sample size is sufficiently large, so the sampling distribution will be normal. It will be normal with the mean of the sample mean is equal to the population mean, which is 35, and the standard deviation of the sample mean is equal to sigma over the square root of n, and the sigma was 42, square root of 36. You can do this calculation. 36 is the square root of 36. The sample size is 36. So you can do this. This is so standard deviation of the sampling distribution comes out to be 42 divided by 6, and you can do this computation. So I hope you are able to understand the central limit theorem, and using these two examples, you are able to understand how we can apply sampling distribution, how we can apply central limit theorem. Thanks for watching.